Hello students, today we are going to talk about the acids and bases. So this chapter is divided into the two sessions. So let's start with the first session with a great enthusiasm. Okay, so I'm going to share the screen. Now we're going to talk about the acids, bases and salt in the whole session. So what are the objective of this session? That is more important. We're going to talk about the acid versus bases. Then we're going to talk about the definition of acid and bases. Then we will learn about writing the formula. So let's start with the lecture. So let's talk about what are the acid, bases and the salt. We are much aware about the acid, bases and salt, but now we're going to talk about in chemical format. So what are the terms we have to understand? What is acid? Acids are the substances that form hydrogen ions, H plus, that is aqueous, when dissolved in the water. So what is the primitive definition of the acids? A substance that form a hydrogen ions when dissolved into the water. Example, hydrochloric acid HCl gives H plus along with a Cl minus ions. Sulfuric acid formula is what? H2SO4. You can see on the screen. Gives 2 hydrogen ion along with SO4, 2 minus ions. Nitric acid, that is HNO3, gives H plus along with the NO3 ions. So these are the acids. So what are the acids? Which donates H plus hydrogen ions into the when dissolved into the water. Now let's talk about the bases. Bases are the oxides and the hydroxide of a material that reacts and neutralize acid to form the salt and water only. Bases which are soluble in water are called alkalis. See, underline this. Bases which are soluble in water called as or not term as alkali. Not all bases fit into this category. Example, ammonia. So here we are going to talk about basically about the alkali and the ammonia. So what are the acids which donate H plus? What are the bases which donate OH minus ion? Okay, so these are the terms we have to understand. So let's move further. Alkalis are the substances that form hydroxide ion, that is OH minus ion in the water. Example, sodium hydroxide, that is NaOH. You can see on the screen, and which gives a sodium ion along with the hydroxide ion. Now calcium hydroxide CaOH twice gives calcium 2 plus and 2OH minus ion. So have you noticed something? In case of acid, those who are in case of H2SO4, which is going to donate 2H plus. In case of CaOH twice, that is calcium hydroxide, which is going to donate OH minus 2 ions. So these are the things we have to observe. Okay. So what is the main reason here? We are defining the acid and bases on the basis of the dissolvability or solubility in the water. Now, in acid solution, there are more H plus ions than OH minus ion. In alkali solution, is a vice versa. OH minus ions will be more as compared to the hydrogen ion. Acids that dissociate, that is ionize. What is the another word for dissociation? Ionization. Are more OH minus ions than the hydrogen ions. Acids that dissociate to large extent are strong electrolytes or strong acids. Acids that dissociate only a small extent are called weak acids or weak electrolytes. So what we are studying right now, strong electrolyte and weak electrolyte. On the property of extent of dissociation or ionization, we are categorized into the strong or a weak acids, or it's called electrolyte as well. Why it's called electrolyte? Because it dissociates. That's why it's called electrolytes. Bases can be strong or a weak depending on the extent to which they dissociate and produce OH minus ions in the solution. Most metal hydroxide are a strong electrolytes and strong bases. Ammonia, NH3, is a weak electrolyte and weak basis. So these are the things we have to understand. So it is a number of the ionized. See what we have learning over here. It is the number of ionizable H plus ion present in an acid. Example, in case of HCl, is a monobasic. Why it's monobasic? Because it's going to donate only H plus. Only one hydrogen ion is going to donate. So that is term as a monobasic. In case of H2SO4, see earlier I just discussed this. I'm going to discuss in a detailed manner. In case of H2SO4, it's called a dibasic because it's going to donate how much ions? 2 H plus ions. In case of H3PO4, that is tribasic. Why? Because it's going to donate 3H plus. So this is how you are going to categorize into the monobasic, because it donates 2H plus. Sorry, 1H plus. Dibasic, 2H plus, and tribasic, it is 3H plus. So according to how much ions they are, dissociation is takes place. According to that, the naming is takes place. So this is how we have to interpret this. Now, this is called basicity of acid. See, name is quite different. Why? Basicity of acid or acidity of the bases, because they are donating H plus. How much donation is H plus is done, according to that number basicity is determined, and it is called basicity of acid. Now let's talk about the acidity of the base. This is vice versa. See, in case of acidity or basicity of the acid, we have learned how much H plus can be produced or ionized from the acid. Now in this case we are going to talk about how much OH minus are dissociated on the basis of, in case of bases. So in case of NaOH is the monobasic, only OH minus ions is getting there. Then in case of CaOH twice diabasic, because two OH minus are getting over here. So this is the reason it's called diabasic. मम्मी आवाज कमी करशील का करू? हाँ काहीच नको करू. Now let's move to the next part. Okay, so here we are going to talk about the common strong acids and their anions. So here is a list of, see, you can see HCl, hydrochloric acid. Formula is written as what? Anions from Cl minus, that is chloride ion. HBr, see, all our hydrogens are there, that's why it's represented as acid. HBr, hydrobromic acid, Br minus, bromide ions is there. So students, have a look on this slides. I will talk about some important points over here. So just have a look on this slides. Okay, in case of HI, it's called hydroiodic acid, that is I minus, HNO3 nitric acid, SCl4 perchloric acid, SClO3 chloric acid, H2SO4 sulfuric acid. Now you can see in the case of sulfuric acid at the end, you can see my cursor, hydrogen sulfur ion is there and sulfate ion is there. That means that in case of H2SO4, it can donate only one hydrogen or it can donate both of the two hydrogens molecule. So this is how we have to interpret this. Okay. So just have a look on this manner. Okay, let's move further. In next slide, we're going to talk about, see, we learn about the definition of acid and bases up till now. So in the next slide, we're going to talk about in these slides, we're going to talk about common weak acids and their anions. So we have learned about the strong electrolyte, weak electrolyte will dissociate faster as compared to the weak electrolyte. The extent of dissociation of the weak acids and acids and bases are very less as compared to the strong electrolyte. So HF, that is hydrofluoric acid, formula is F minus, fluoride ions is there. In case of anions, we are discussing formula of anions. Now CH3COOH, that is acetic acid. The anion over here is CH3CON, that is called acetate ion. In case of HCN, it is cyanide ion. See, you can see here in last case we have learned about the sulfuric acid. Now we are going to learn about the these things, that is H2CO3, that is carbonic acid. So it can donate whole hydrogen twice or only one hydrogen. If it loses one hydrogen, it's called hydrogen cyanide ion. If it's going to lose all the hydrogen, it's called carbonate ion. In H2SOCO3, that is sulfurous acid, same case happen with the phosphoric acid, same case happen with the oxalic acid. In case of oxalic acid, you can see only one hydrogen is donated, then it's called as hydrogen oxalate ion, but all the hydrogen donated, it's called oxalate ion. So this is the difference between this. So have a look on this. Now let's talk about the naming of the acid. This is not quite important, but we have to discuss this because this is mentioned in your syllabus. So binary acid, that is H plus, and the non-metal hydro, that is non-metal ide plus ic acid is added. In case of HCl, see, look at the example, you will understand much better. HCl hydro, H for hydrogen, hydro, Cl for chloric, and the ic acid is added. In case of ternary acid, it is called polyatomic ion, that is HNO3 nitric acid, HCN cyanic acid, HNO2 nitrous acid. Student, you have to practice it, then only you have to understand this. Now let's talk about this table E, selected polyatomic. What is polyatomic? They can react more than one, so that's called polyatomic. Na3 is nitrate, Cn minus is cyanide, NO2 minus is nitrite. So this is how you have to interpret this. This is all about naming of the acid. Now, how to write the formula of the acid? This is most important part. Acid formula get written like any other. Write the H plus ion. See what we have to write. I'm going to read it first, then we're going to solve simultaneously. Then figure out what the negative ions is based on the name. Cancel out the charges to write the formula. Don't forget the aqueous. Aqueous stands for water dissolved or solubility. After it, it's only an acid if it's water. Now let's talk about the example. Carbonic acid H plus 1 CO3 2 minus. This is what valency of hydrogen. This is valency of this group. So it will be written as H2CO3. Why H2CO3? What is the valency of CO3? 2 minus. So how much hydrogen is going to react? 2 hydrogen. That is why H2CO3. We have to write aqueous. That is very, very important. Now chlorous acid H plus ClO2 C minus 1. The whole group has a valency as a minus 1, or we can say oxidation number is minus 1, or you can say directly in a short format charge is minus 1. So how many hydrogens are there? One hydrogen only there. In case of hydrobromic acid, HBr is there. So this is how we have to write the acid formula. Now, properties of bases. Bases react with the fats to form a soap and glycerol. This is process called saponification. So whatever we using soap for a daily purposes is nothing but your bases only, and that is the process from where it's generated called as a saponification. Bases have a pH of more than 7. Dilute solution of the bases tastes bitter. Bases turn phenolphthalein pink, litmus blue, and the bromothymol blue. So what is this? This is are the indicators to identify what are the bases that we have to use phenolphthalein, which gives the pink coloration, litmus paper gives you the blue coloration, bromol blue will be the remain blue only. Bases neutralizes acid, we know that, that's why we use a gelocil for the digestion. When there is acidity problem is there, we use the bases to neutralize it. Okay, so bases are formed when the alkali metals or alkaline earth metals react with the water. The word alkali and alkaline mean basic as opposed to the acidic word. So what is the opposition of the acidic word? Is the basic, or we can talk about as a alkali. So these are the properties of bases. Now naming of the bases as compared to the acid is quite similar only, but here we have to mention some points. See, bases are named like any ionic compound. The name of the metal ion first with a Roman numerical if necessary. If there, we have to add it. So hydroxide, at the end we have to talk about the hydroxide. FeOH twice aqueous, iron hydroxide. FeOH thrice, iron hydroxide. Aluminium OH thrice, aluminium hydroxide. See, in case of NH3, you can see my cursor is the same NH4OH. So it will be called as also called ammonium hydroxide. Getting my point? So this we have to understand. See table L, you have to see common bases. Sodium hydroxide, potassium hydroxide, calcium hydroxide, and aqueous ammonia are the common bases. Now, in case of NH3 aqueous ammonia, you will not find about the hydroxide term, but it act like an acid. So ammonia act like a base over here. That's why it's called as the aqueous ammonia. We have to term into the common bases. Formula writing for the basis. Let's directly talk to the talk with the example right now. Let's talk about examples. Calcium hydroxide Ca2 plus OH minus. That's why CaOH. See, we have to consider whole this group OH minus 1. We have to consider whole this group. Then only it's CaOH OH twice. Potassium hydroxide KOH because K plus 1 OH minus 1, that is 1 1, and then charges cancel out and the whole become neutral. So that way there is no charge on the this molecule. Lead hydroxide Pb2 plus, or and in this case OH minus 1. So PbOH twice has to be there in this case. Lead oxide Pb plus 4 and OH minus PbOH 4. So this is how you write the formula of bases. Now let's talk about the physical properties of acid and bases. See, we have learned about right now. See, properties of bases, how to write the acid formula, how to write bases formula. Now we are moving to the another part that is termed as properties of acids and bases. So what is the first properties of acid and bases we're going to talk about? Okay, so let it display on the. Okay, so acid tests are vinegar, lemon juice, you know about that. Acids are harmful to the living things. Yes, living cells is very acidic because acidic what concentration is higher, So there is a damage of the cell can be takes place. Aqueous solution of all the acid contains hydrogen ions. Acid turns blue litmus red. Strong acids are corrosive. These are the properties of acids. As we move further, we're going to talk about the bases. So what are the properties of the bases? Let's talk about. Okay. Now, in case of bases, bases are alkalis are tester beater. Strong alkalis are corrosive. See, mild alkalis are not corrosive as much as we are going to talk about the acids. But strong alkalis are quite corrosive. Aqueous solution of alkali contains hydroxide ion. Alkali turns red litmus blue and they are soapy to touch. So this is the slide is exactly going to talk about the differentiation between the acid and bases. See, let's pick up only one or two example. The bases are soapy to touch, whereas acids are not soapy to touch, they are corrosive. Then the strong alkalis are corrosive, strong base are corrosive. This is a common point. What is the uncommon point here? Indicators are quite different. Okay, so we have to understand if the question arises in examination, write a differentiation between acid and bases, you have to cover this much points. Okay, now let's talk about the chemical properties of acid. When you talk about the chemical properties of acid, what comes in our mind? See, so let's talk about the chemical properties of acid. We're going to talk about the reaction first with the metal. So metals above the copper in the reactivity series will react with the acid, giving the hydrogen gas. See, you can see a magnesium. Magnesium react with the H2SO4, which gives the MgSO4, and hydrogen ion is liberated. Getting my point? So here, what happened with when acid react with the metal, there is a liberation of hydrogen gas. Now the second will be with the bases metal oxide and hydroxide. Now the base dissolve in the acid and neutralize it. We know that neutralization reaction. It is a salt formation reaction also. So what is a salt? It is the addition of acid and base part and which leads to the formation of salt. If you add H2SO4 aqueous along with the copper oxide, which leads to formation of CuSO4 along with the formation of water molecule. So what is the salt over here? CuSO4 is termed as a salt over here. Okay. So H2SO4 react with the CuO, that is copper oxide, leads to the formation of water along with the salt. So this is the reaction which leads to the formation of the salt. With metals carbonates, with the metal carbonates, effervescence. What is effervescence? A bubbling, a vigorous bubbling is called effervescence occurs. Water and the carbon dioxide gas is produced. In case of HCl, CaCO3 is reacting, that is calcium carbonate is reacting along with the hydrochloric acid. There is a formation of salt, that is CaCl2, that means calcium chloride along with the water, but there is a effervescence because of what? Carbon dioxide. So there is a formation of carbon dioxide. See, the in case of hydrogen gas was liberated, there is no effervescence as such. But in case there is a vigorous bubbling and called as the effervescence because carbon dioxide is liberated. Now neutralization reaction. What is neutralization reaction? Salt formation reaction. So whenever there is a H plus OH minus, H2O is there. H2O is not salt, but we are considering as that because acid plus base is formed over here. So acid plus base, water is formation there along with the salt. Only H and OH is reacting, only water molecule is forming. But when acid part and basic part is reacting, water is forming because from the acid H plus comes, from the base OH minus comes. When they combine, water molecule is formed and that is called double replacement. Whenever HCl is react with the NaOH, there is formation of NaCl salt. This is a common example we have studied from the many years. Let's go to the next example, that is H2SO4 when react with the KOH. Now tell me one thing, H2 and OH will be form the water and this K and SO4 will be formed the salt, that is K2SO4. Potassium sulfate will be formed. HBr along with LiOH, what going to form? Just tell me. Okay, so these are the example for you. Just copy down this example. If the HBr react with LiOH, okay, I'm going to solve one and you're going to solve the further one. The HBr, in case of HBr, hydrogen is there, OH is there, there is a formation of water molecule there. Then Br and lithium. So lithium bromide will be formation of there. So let's take example of last one. Which salt? You have to listen very carefully. You have to listen very carefully which salt is going to form. In the last case, H3O is there and the MgOH is there, right? So which salt is going to form? MgPO4. Okay, so this is the answer for that question. Okay, now let's talk about the formation of the hydronium ion. In case of hydronium ion, that is H3O plus, the hydrogen ion, that is H plus, does not exist as much as in the aqueous solution. Hydrogen ion combine with a water molecule to give a more stable species that is called hydronium ion. So what we are understanding right now, see, we have learned about that in neutralization, H plus OH minus react to form a water, but formation of hydronium ion leads to what? The hydrogen ion, that is H plus, and OH minus, that is water molecule. But water molecule is not stable because of the lone pair of electrons of the oxygen, and it's react with more hydrogen to form a hydronium ion, that is H3O plus. Now in this case, HCl plus H2O going to form a H3O, that is hydronium ion, along with the chlorine ion. So whenever the acid dissolved into the water, the one H plus is gained by the water, form the hydronium ion, and the remaining ion is formed. In case of HCl, Cl, chlorine minus ion is formed. Now let's move further. Acid can contain different numbers of acidic hydrogens and can yield different numbers of H3O plus, that is hydronium ion, in the solution. Let's talk about the sulfuric acid. See, we have discussed that sulfuric acid can donate whole two hydrogen or only one hydrogen. Phosphoric acid have a liberty to donate three hydrogen at once. It can donate whole three hydrogen, or it can donate only one hydrogen. So depends on that how it does so. So just have a look on this. In case of H2SO4, it's going to donate this HSO3 4 minus along with H3O plus. In case of if it donate only a whole hydrogen atom, it's formed like this. So this is how it actually interpretation takes place. So here we done with this of formation of hydronium ion. Let's move further. Now let's talk about the uses of acid. HCl in the stomach. We know when you talk about the acid in the stomach, it helps in the digestion, it helps in the killing the bacteria. Biologically, it is quite very important for the digestive purpose. It activate the enzyme and it smoothen the whole the digestion process. H2SO4 in a car batteries as a drying agent. It is used in the drying as a drying agent in a car batteries, that is H2SO4. HNO3 in a manufacture of fertilizers because nitrate ion we have to generate. That's why it's used. Then ethanic acid is a food industry. We are much aware about that. Ethanic acid is used in the food industry for various purposes. Fatty acid in the soap making. Yes, we are aware about that. Whatever the saponification process is done by the fatty acid. See how much more number of carbon, more number of, you can say, soapiness is there. So that is saponification. Ascorbic acid in the medicine, we use the vitamin C, that is ascorbic acid. So these are the uses of the acids. Now chemical properties of bases. Let's study about that. Let's talk about the neutralization. We know that, see, in the case of acid and bases, the common property is neutralization because acid and base react to form the salt along with the water molecule. That is neutralization. We already discussed that. We know the common example NaOH plus HCl, NaCl will form along with the water molecule. Now let's talk about the ammonium salt are decomposes when mixed with the base, example sodium hydroxide. The ammonia is readily detected by its pungent odor, that is a strong smell, and by turning damp red litmus blue. So whenever there is a reaction of sodium hydroxide, you can see the formula NH4Cl, that is ammonium chloride. There is a formation of salt along with water, and the one more gas is there. It's called ammonia, and which is very pungent, or we can say has a strong smell. Ironically, when you talk about how the ion form, NH4 plus OH minus form the water, and NH3 is liberated actually. So in case of NH4Cl, it's got dissociated, then NH4 plus get added with the OH minus form water molecule along with ammonia is liberated. This reaction can be used to prepare ammonia gas and as a test for the ammonium salt. So this is a how can you detect the ammonium salt? You have to add the NOH, and if you find a smell is coming, strong smell, pungent odor is coming, then it is detection of the ammonia, and that represent or indicate that the ammonical salt is there. So this is how we use the chemical property. Now chemical properties of bases we are going to talk about. Alkalis are used to produce the insoluble hydroxide precipitates of many metal ions from their soluble salt solution. So in this case, what is going to happen? 2NaOH plus CuSO4 is going to react to form Na2SO4 along with copper hydroxide. So ionically, when you talk about copper reacts with the OH minus to form a copper hydroxide ion. So this reaction can be used as a simple test to help the identify certain metal ions. So this is the test we use. That is, we have to add NaOH with the CuSO4. Suppose in case of CuSO4, if we add FeSO4, that FeOH twice, and will give the another color. If case of CuSO4, MgSO4 is there, MgOH twice will be formed. Color will be different, and it gives the test for the help identification of certain metal ions. So this is the use majorly used in a laboratory purposes for the detection of the ions. Types of oxide. There are two types of oxide, acidic and basic. Let's talk about as basic first. On the left and middle of the periodic table, let's talk about the periodic table. There is a left side, on the middle side is there. Okay, are the basic metal oxide. There is Na2O, MgO, magnesium oxide, copper oxides are there. So when you talk about the 2HCl react with the MgO, form MgCl2 along with the water. Copper oxide react with H2SO4, H2SO4 form a CuSO4 along with the water. These metal oxide tend to be the ionic in a bonding character with the high melting points. As you move left to the right, the oxide become less basic and more acidic. So this is the observation we have to understand. Now let's talk about the acidic oxide. On the right periodic and on the right of the periodic table, the acidic oxides are there. Majority they are carbon dioxide, PTO5, then SO2 is there, SO3 is there. This tend to be the covalent in the bonding character with a low melting and a boiling points. Those of the sulfur and phosphorus are very soluble in water to give the acidic solution, which can be neutralized by the alkali to form the salt. Look at here, SO2 plus H2O, when they react form H2SO3. SO3, see here 3 is there, react with the water, it form H2SO4. So whenever the formation of H2SO4, SO3 has to be, that is oxide of the sulfur react with the water, then H2SO4 acid will be formed. Now types of oxide, amphoteric oxide. Okay, we have learned about acidic, basic. Now amphoteric, the name itself tell about the amphoteric. That means it contains possess both acidic or basic thing. They are mostly metallic oxide. They react with the both acids and alkali. They are usually reactively insoluble and have a little effect on the indicators. An example is aluminum oxide dissolved in an acid to form a normal aluminum salt like a chloride, sulfate, and nitrate. However, it is also dissolved in a strong alkali like sodium hydroxide solution to form a aluminate salt. This is amphoteric nature. Amphoteric nature, in case of in front of base, it act like acid. In front of acid, it like a base. That is why it's called as the amphoteric oxide. And main example is what? Aluminum oxide, La2O3. Now, neutral oxide, we're going to talk about the fourth type, that is a neutral oxide. They are non-metallic oxide. They tend to be the low solubility in the water and they have no effect on the litmus paper. Do not react with the acid or alkali, example, carbon monoxide along with the nitrogen monoxide and the water. There is no way of simply predicting this kind of behavior from the periodic table pattern. So this is quite difficult to identify. That is called neutral oxides. Now, in the periodic table, we have reached to the last part of this session. we're going to talk about the periodic trends in oxide. So we have learned about acidic oxide, learn about the amphoteric oxide, basic oxides, and the neutral oxide. So what we have studied is going to nutshell into this. So let's talk about when you move from the periodic table from 1A or from A 1A to the 7A, it will be increasing acidic character. But when you're moving down from above top to bottom, it will be increasing the basic characteristic. These are the trends found in the periodic table. So whatever we have discussed right now, let's study this or let's recollect it. Okay, so what we have learned up till now so far, we have discussed about the acid, that is which donate the H plus. We talk about the base or alkali which donates OH minus ion. Then we talk about the properties of acid and bases, this differentiate between the acid and bases. Then we have talk about the properties in regarding the reaction. We talk about the neutralization reaction. Then we talk about the acid reaction, basic reaction, and at the end we had talk about the oxides. So this is much we have covered in the first station. In the next session, we're going to talk about the salt. So be prepared for that. Thank you for paying attention.